Today, we're digging into a project with a pretty wild idea at its core. How do you take the stuff nobody wants, industrial waste, and turn it into the very thing that fuels the AI revolution?
It sounds almost impossible, right? How on earth do you power cutting-edge AI with toxic water and, leftover natural gas? Well, this is the central question behind a project called Operation Genesis. So let's unpack just how they're pulling this off.
All right, our story starts in the Delaware Basin, which is this huge stretch of land in West Texas and New Mexico. And it's a place that's just full of contradictions. Unbelievable wealth right next to incredible waste. So, let's get into what's happening here. First, you've got all this natural gas that comes up from oil drilling. The problem is, there are no pipelines to take it anywhere, so it's basically stranded, useless energy. Second, you've got this massive environmental headache. Hundreds of thousands of barrels of toxic wastewater from that same oil production every single day. And on top of all that, you have this explosive worldwide demand for reliable, always-on power for AI data centers. So you've got three huge, seemingly separate problems, all crashing into each other in the exact same spot. So what do? Well, Operation Genesis comes in with a pretty radical solution, an incredible piece of engineering designed to solve all three problems at once. And they call it the island. The idea here is actually, brilliantly simple. Just picture a totally self-sufficient industrial park, a closed-loop ecosystem that's completely off-grid. It doesn't need outside power, it doesn't need outside water. It literally just takes in the region's waste products and right there on site transforms them into incredibly valuable assets. The whole thing is built on what they call a triple play synergy. Synergy is just when different parts work together to create something bigger than they could on their own. And here it's a simple three-step loop where each step fuels the next. So step 1, you turn that unwanted gas into cheap electricity. Step 2, you use that power for AI data centers and to run a water treatment plant. And then step 3, you take that toxic water and turn it into clean water and valuable minerals. Let's break each one of those down.
All right, first piece of the puzzle, the energy. This is the engine that makes the whole thing go. How do you take worthless, stranded gas and make it the bedrock of a next-gen data center?
The scale we're talking about here is just huge. This is a 500-megawatt power plant built right there, totally disconnected from the main electrical grid. And that is so important. For an AI data center, reliability is everything. They need what's called firm power, electricity that you can count on 24/7. By making it themselves, they completely get rid of the risk of grid failures, which makes their power incredibly valuable.
But here's the thing, they don't just make the power, they're incredibly smart about how they use it. Priority number 1, about 65 megawatts, is non-negotiable. That keeps the water treatment plant running no matter what. Priority 2 is the real moneymaker, 300 megawatts of super reliable, firm power for their AI clients. And then you get to the really clever part.
That last 160 megawatts goes to Bitcoin mining. But it's what's known as curtailable, which just means it can be dialed down or shut off instantly. Think of it like a giant economic shock absorber for the whole facility. If their power generation ever dips, for any reason, they can immediately cut power to the Bitcoin miners, and that protects the really critical, high-paying AI customer, making sure they never lose power. It's just an ingenious way to build in resilience.
Okay, so let's get to the second part of this whole synergy, which honestly feels like some kind of modern alchemy. We're talking about turning 200,000 barrels a day of toxic wastewater into something incredibly valuable.
And the core tech here is something called Zero Liquid Discharge, or ZLD. The name pretty much says it all. The goal is to take this super salty, contaminated water and make sure absolutely nothing is wasted. 100% of the water gets recycled, and all you're left with are solid materials. But, it's never that easy, is it? Treating this water comes with a huge, hidden danger. A risk that, if they don't handle it perfectly, could flip this entire project from a brilliant asset into a total catastrophe.
And that danger is called NORM, naturally occurring radioactive material. In this case, it's radium, which is just naturally in the ground and gets mixed in with the wastewater. Now, if you just boil off all the water, that radium gets super concentrated in the salt that's left behind. And that salt would then be classified as radioactive waste. We're talking a potential billion-dollar disposal nightmare.
So the key, the absolute linchpin of this whole water operation is getting that norm out first. And they do this with what they call a gatekeeper system. It's an upstream chemical process that safely pulls the radium out. This one relatively cheap step is what makes the whole thing possible. It guarantees that the 4,200 tons of solid waste they produce every day is safe and non-hazardous.
Okay, so after all that, what do you actually get? Well, get this. After running 200,000 barrels of toxic water through the system, they produce a staggering 190,000 barrels of fresh, distilled water every single day.
But remember, a place like this, it's thirsty. The power plant, the data centers, they all need a massive amount of water for cooling. So how much? Their total daily need is about 121,000 barrels.
And this is where the magic really happens. Do the math. They make 190,000 barrels, but they only need 121,000. That means this facility doesn't just take care of itself, it actually becomes a net producer of 69,000 barrels of clean water every day. In the middle of the desert, a toxic liability is literally transformed into a life-giving surplus.
So yeah, the engineering is just phenomenal. But how does it make money? Let's talk about the economics, because this thing is designed to be an incredible arbitrage machine. And arbitrage is really just a fancy way of saying you profit from a price difference. Buy low, sell high. And this whole place is built to do just that.
First up, the water. Right now, oil companies have to pay about $1.50 a barrel just to get rid of this toxic water. Operation Genesis just flips that completely. They charge those same companies a fee to take the water. So what was a huge cost for one industry becomes a guaranteed revenue stream for Genesis.
But the real moneymaker? That's the energy. I mean, look at this. Because their fuel is basically free waste gas, their cost to generate power is way down here. But the price they can charge for that super reliable power for AI, it's way up here. That massive gap between their cost and their price, that's what really drives the project's profit.
So you add it all up, and you've got not one, not two, but 5 different ways this thing makes money. You've got the high-paying AI contracts, the flexible Bitcoin power sales, the guaranteed water fees, selling all that surplus fresh water, and then finally selling the valuable minerals like lithium and even uranium that they pull out of the brine. It's just a really robust and resilient financial model.
Okay, let's just step back for a second. We've seen how Operation Genesis turns waste into power, toxic water into fresh water, and liabilities into assets. But what does it all mean? What's the bigger picture here?
And that really leaves us with the big question, doesn't it? Is the island just a one-off, a really clever solution for the very specific problems of the Delaware Basin? Or is this a whole new blueprint for how we power the future? A model where we put energy demand right next to stranded resources to create these closed-loop, self-sustaining industrial worlds? The answer to that could honestly shape the future of both energy and computing for decades.